In this video, we're going to learn how to do operations in scientific notation, meaning how to add, subtract, multiply, and divide. Now, as a teacher, I always try to make it clear when something that we're learning is like really important. This is a core idea that you need to really understand for this year. And the flip side of that is that I think it's also my job to let you know when what I'm teaching you is more of an introduction. It's like I need you to know that you've seen this. It's not something we're going to be practicing a ton. Yes, it'll be on the quiz, but this can be tricky. If this is really confusing to you, do not panic. I mostly just want you to know that you're exposed to it, you've seen it before. Sometime later when someone else teaches this to you again, you'll understand it better. Okay? Consider this to be a little introduction. All right, so we're going to start with multiplying and dividing because that's actually a little bit easier in scientific notation. So the first thing that you do if you're trying to multiply and divide, I guess I should say the whole point here is that if you're dealing with numbers that are so big or so small that bringing them out of scientific notation to do some math with them and then putting them back into scientific notation is truly obnoxious, then we need to find a way to do those operations while leaving them in scientific notation, okay? It'll help with mistakes because it's really easy to make mistakes when you have tons of zeros to worry about. So to multiply and divide, your first step is going to be to multiply what I'm going to call the decimal part, the stuff that's before the times 10 to the power, even though it may not actually be a decimal. Multiply the decimal part. There's probably a fancier word for that I don't know. It's fine. Next, you are going to multiply the exponent part, right? Like the magnitudes. Multiply the times 10 to the whatever part. And then finally, you are going to convert back into scientific notation. And that's not always necessary. Sometimes it'll just beautifully end up exactly the way you need it. All right, so let's do an example. Let's say that we are trying to multiply 1.2 times 10 to the power of 7 by 3 times 10 to the power of 15. Trying to multiply those guys. Ugly. So I'm going to do it step by step. And this works because multiplication is commutative, right? This is a multiplication, like the scientific notation within itself is a multiplication problem, right? This thing times this thing. And then this is a multiplication problem in and of itself. So if I'm multiplying those together, I just essentially have 4 pieces that I'm multiplying, so I can multiply them in any order that I want. I hope that makes sense. So I'm going to do it piece by piece. So I'm going to multiply the decimal part. So 1.2 times 3 gives me 3.6. Hooray! Then I'm going to multiply the exponent part. And this is where we get to apply what we learned about laws of exponents. So that tells me that I need to do 10 to the 7th times 10 to the 15th. Well, when they have the same base, then I just add the exponent, right? So that gives me 10 to the power of 15 plus 7 is 22. And then I just switch it back to scientific notation. So my answer is 3.6 times 10 to the 22. And this was a nice example because it ended up, that is proper scientific notation. I know that because it has 1 digit before the decimal. Okay? Woohoo! Hooray! Done. Let's try another example. This time, let's go ahead and do, so that was example number 1. Here's example number 2. We're going to do 2.4 times 10 to the negative 6. So we're dealing with small numbers now. But I'm going to divide it by a really big number. So I'm going to divide that by 8 times 10 squared. Not too big, but big enough. But the same steps apply. So the first thing I'm going to do is I'm going to divide the decimal parts. So I'm going to do 2.4 divided by 8. That gives me exactly 0.3. Okay? Then I'm going to divide this part. I'm going to set it up like a fraction because that's kind of the way I like to see it. So I'm going to do 10 to the negative 6 divided by 10 squared. Kind of hurts my brain, so I'm going to apply my subtraction rule. So I know that that's the same as 10 to the negative 6 minus 2, because that's my exponent rule, right? And that gives me 10 to the negative 8. So that means my answer is 0.3 times 10 to the negative 8. Am I done? Not quite, right? Because this isn't scientific notation. We know that scientific notation needs to have exactly one digit in front. But as long as you keep your head straight, it's not too bad to change back. So what I'm going to do is I'm just going to move the decimal place one spot this way, making it 3 times, and then I need to figure out what my new exponent is. So I took this number and I made it bigger. So in order to compensate for that, I need to make this number smaller so that it ends up being the same total value. So that'll be 10 to the negative 9, because that like gives me that extra 0, right? That's probably the trickiest part, is like changing it back when you need to. Like so. Okay, now let's talk about adding and subtracting. All right, so before we even start adding and subtracting, you should know this only works if you have numbers that are sort of in the same realm, right? So if you have two really, really big numbers, but they're kind of like equally big, this will work. If you have a really, really big number and a really, really small number, you're just gonna have to change it back to standard notation, right? But this works if they're sort of close to each other. They just have like a ton of zeros involved. So your first step is to change both numbers so they have the exact same magnitude or power of 10, right? So they could both be times x to the power of 20. And I'll show you how to do that. It's kind of similar to what we just did. Then you are going to add or subtract the decimal part. Just like what we did before. And then with multiplying and dividing. And then finally, we are going to convert back to scientific notation if needed. All right, so let's take an example where we have two really, really big numbers. Let's say that we have 8.95 times 10 to the power of 30. And we are trying to add it to 3 times 10 to the power of 28. Notice, I'm specifically picking ones where they're both huge, but they're sort of in the close to being the same magnitude, right? Which one's bigger? Hopefully you agree that to the power of 30 is bigger because it's going to have like 2 extra zeros on it than this one is. So my first task is I need to change them both to have the same magnitude, the same power of 10. And so I need to pick. I either am going to change them to be both a power of 30, or I'm going to change them to both be to the power of 28. Either way is fine. I think they're both equally confusing. So we'll just go with one or the other. I'm going to pick to change them both to be the power of 30, just because. So that means that this number needs to change. So I need to rewrite it so that it's something times 10 to the power of 30. And if I'm making this number bigger, then I have to make this one smaller. So instead of having the decimal be right there, I have to move it over 2 spots, because from 28 to 30 is 2 spots away. So that means that this number is 0.03 times 10 to the 30th. No longer scientific notation, right? But it means we can add them. So that means that I can now add 8.95 plus 0.03, which gives me 8.98. And then that's going to be times 10 to the power of 30. So I guess it's actually good that I picked 30 because this ended up in scientific notation and I didn't have to like change back again, right? If I changed them both to 28, then I would have had to do that adjusting again. All right, let's do another example. Just kidding, I think we're out of time. So this one will be the practice problem. So you're going to do 3.25 times 10 to the negative 4 minus 1.5 times 10 to the negative 5. And I purposely made our exponents not too big this time, so it is actually reasonable for you to check your work by converting them back to standard notation, so it does have all the zeros, and then subtracting and seeing that it works. Okay? Give it your best shot.